New technologies are changing the world. They're also making the cars manufactured by the Volkswagen Group more efficient, safer, and more customer-friendly. The nature of car manufacturing is also changing in a similar way. In fact, the next batch of innovations is so extraordinary that experts are already declaring the dawn of a new industrial era, Industry 4.0. So what does manufacturing look like today? Traditional car production involving hundreds of identical vehicles lined up in a row no longer exists. The options available to customers are now so vast that each car becomes a unique and individual object. Cars are now manufactured to order. Data makes its way from the customer's order to the Volkswagen Group's systems and then to each individual section of production. A car consists of many thousands of individual parts. The press shop processes blanks for the bodywork. In the body shop, the car is baptized. In other words, it's given an RFID tag that can track it via radio frequency. This establishes which car body belongs to which customer order. The paint shop also receives information from the system world. In sequencing storage, the cars are placed in an optimal order for assembly. From here, information is transmitted to suppliers and pre-assembly as to which part is required when and where. In final assembly, the finished car emerges. The Volkswagen Group manufactures its cars using state-of-the-art technology, but development and innovation never stop. What does the future hold in store? Today, everybody is talking about Industry 4.0. It is a term used to describe a variety of innovative production processes. But what exactly does it mean? The Volkswagen Group has been shaping the future with groundbreaking projects for many years. Here are some recent examples. Digitalization. The digitalization of all elements of production is essential for a new era in industrialization. Everything is given a virtual likeness in the system world. The result is an Internet of Things. Example, 3D printing. Pressing tools are no longer shaped in a laborious manner. Instead, these tools can be made from steel granulate in a 3D printer. It's a technology that opens the door on completely new possibilities for design, with a level of precision unknown until today. Example, human-robot cooperation. In the past, protective grids separated robot arms and employees. In the future, employees and robots will work increasingly hand in hand. This is made possible by new security sensors. Robots take on especially monotonous and arduous activities. Today, robots already play a part in contributing to ergonomic workplaces at the Volkswagen factories in Chemnitz and Salzgitter. Example, Big Data Monitor in logistics. The Big Data Monitor enables for the rapid visual processing of data from the 1,200 suppliers of the Audi factory in Neckarsulm. Where are the potential bottlenecks? Where is the greatest need for action? This data is now easily accessible at all times. The intelligent factory of tomorrow paves the way for efficient and cost-effective production unlike ever before. Industry 4.0 also means brand new opportunities for employees. The Volkswagen Group has already begun actively preparing its workforce for the future. The world is changing, not only in the automotive industry. Everything is in motion, and the Volkswagen Group provides the
I'm ready.
We make no secret of the fact that we are determined to head right to the top of medicine. That's what we're doing. This is a beautiful example of it.
I saw a machine that I'd seen 7 or 8 years ago in a lab building in Germany at Siemens, which was now a reality. And when somebody explained to me how it was going to be used, what more can you say?
We had this vision of what we thought the future of the operating room should be and what the future of surgery should be. And having an administration that was supportive of this future vision, we were able to, with a lot of people's help, create these rooms, which are not only operating rooms that have the state-of-the-art of technology, but operating rooms of the future, where we're going to actually change what surgery is.
We're the first hospital in the country to have 2 of these units in the operating room. Just the whole concept of what is surgery or what is needed to treat diseases is changing. We're going to redefine what a surgical specialist is even, because a surgical specialist now has to be an information technology expert. They have to be a radiologist, endoscopist. They have to be able to do minimally invasive surgery. They got to be able to do conventional surgery.
This revolution is really this merging of intervention with imaging. Imaging equipment that allows us to be better surgeons and allows us to be minimally invasive surgeons.
In this room, at least 12 different image devices so that you can have multiple inputs.
It starts with the electronic medical record. Everyone has access to it. The surgeon has access to it. The anesthesiologist has access to it. The nursing team has access to it. We can communicate with the pathologist upstairs. We have the images from the endoscope, from the microscope. Everything can be viewed at by the clinicians and the people that are taking care of the patient, so we can get everyone's feedback instantaneously.
We're optimizing the patient's care by putting in the hands of the surgeons every conceivable piece of information in the room, helping the physician do the best job for the patient.
And it's not just the surgeon, it's the nursing team, it's the anesthesiologist, it's the whole team.
If you notice attention to detail, where the nurse's station over there is, that desk faces the patient. In all our existing operating rooms and in most operating rooms around the country, the nurses' desks and the computers are facing the wall. That certainly adds to the patient safety.
You can always accomplish much more when you bring many minds from different disciplines together. I think that's really the exciting thing about being an institution like New York Presbyterian. I mean, we couldn't have done this without the help of donors like the Helmsley Foundation to mobilize the kinds of resources to build this kind of environment. Basically what this machine can do is if you take fluoroscopy and spin it around the patient, you get a 3-dimensional image. You can see blood vessels in 3 dimensions. You can see solid tumors in 3 dimensions. You can see bone if you're putting in instrumentation and hardware.
By that spinning motion, you can also create cross-sectional images. What you can start to do now is you can start to say, I'm going to operate on the intestine. This machine will give you simultaneously the intraluminal or inside channel picture, and I'm going to be able to see outside at the same time. And this has the capability that we can overlay those images. So you can start to do what I was saying, Jerry. Think about intestinal surgery where the patient doesn't even have to go to sleep. The average patient nowadays is older, more frail, has more serious accompanying diseases, and so the possibility to eradicate their problem, minimize hospital stay, minimize pain, that's what it's all about, man.
We really want to push the envelope a little bit, and when we start doing that, we don't know where we're going to be able to go with this, and I think that's really the excitement. The excitement is redefining what we're going to be able to do, or from what the standard of what surgery is now, so that with this we can redefine ourselves and really change the way things are done.
And to me, what it represents, not the state of the art, we're ahead of the state of the art.
If so, help could be at hand in the form of a robo-chef that you can install in your kitchen. This kitchen wizard has been programmed to mirror the movements of humans slaving over a hot stove, but before you get too excited, it is 2 years away from going on general sale. But its Russian-born and UK-based creator believes it can be a tasty addition to any household.
You can cook in this module by yourself, by your hand. The model will recognize your movement, save it like a program, and after it's executed the same way like you do without you. You can save this program unlimited times. You can save it for yourself. You can buy the recipe from any kind of chef in the world. Press the button, choose the recipe, load the ingredients, and start cooking without your help, and start watching how these people who generate the recipe cook.
Well, the robo-chef is causing quite a stir, not just in those pots and pans that you saw. It has captured the imagination of quite a few of you, particularly on the internet. And most people do seem to like the idea, although some do say it takes the fun out of cooking. And connoisseurs do warn it will never replace the human touch.
We should never take the human element away from that. I still think nothing beats a person making your food who puts love into it and care and attention, and sometimes mistakes make great things. So I don't think it will ever take over human chefs and people cooking, because we love to cook, it's artistic, so for some people it's relaxing, for some people it's super creative. So I think it'll have its place, but I don't think we'll ever lose the human chef.
The issue is not whether or not automation will replace jobs in our context, because what we've done is create 120 new jobs in Silicon Valley.
What does the robot do?
The robots are doing the tasks that are unsafe, that are repetitive, that are boring, that aren't really human-centered tasks, like sticking your hand in and out of an 800-degree oven, 2,000 times a day. And the humans are doing human-centered work, collaborative work, creative work.
Like coming up with the cheesy E. I'm looking at Pineapple Express.
That's right.
The sweet corn pizza. I'm looking at some of your pizzas. That's what you do. So, is this cheaper for you? I mean, The idea is that they're not going to take sick days. Did you decide to go this way for a specific reason?
The problem that we were solving was how to get healthy food onto your table affordably. So yes, there's absolutely a margin play going on here. We're using automation, and we're using technology to decrease some of our labor costs and occupancy costs, but we're reinvesting the surplus from that technology into better jobs.
Pizza's pretty cheap. Are your pizzas cheaper?
Our pizzas are as affordable as our competitors, even
How
though a 14-inch pepperoni pizza is going to cost you $10, just the same as it would at a competitor. But even though it's got locally sourced, sustainably farmed ingredients, and it's the best quality pizza.
Are your pizzas cooked in a central oven or in a retail location, or can I walk in and get a pizza, or is it all delivery? Tell me about that.
This is
how much do these things cost, these robots?
Zoom is a delivery-only concept.
Delivery only.
So there is no physical storefront. Guess what that means? That means I don't pay 10% of my revenue in rent. That's another thing that we're doing to build profitability. All of the pizzas are prepared using our robot-enabled pizza assembly line in a central facility. But the way that we get the pizza to you is in a special vehicle that cooks the pizza while it's being delivered to your door. So it's always coming.
So what am I seeing going on here? I thought I just saw something come out of an oven.
It's getting cooked in the video.
There are people. They've got people.
Yeah.
No, I see the people. They're not getting cooked.
That's our power baking oven. So on a prediction shift, early in the morning on our production shift, we're par baking. That's right. And then we're finishing them the moment that they get to you.
You can buy par baked bread that you bring home and put in the oven.
Yes. So the pizza is cooked finally in the truck as it comes to my house.
Yes, we have a sophisticated inventory-sensitive routing system that tells the ovens within the truck exactly when to turn on, when to turn off, how hot to cook for, so that your pizza's cooked to perfection.
I think other pizzerias are doomed.
It's a tragedy that as the world outside school changes faster and faster, the majority of American kids are not being set up to succeed in the future that's coming. We're entering a world where there's not a lot of value on just kind of sitting there and doing what you're told. Increasingly, a computer could do that kind of stuff. we are eventually going to create a new model of education suited to the 21st century instead of the last half of the 19th century. This is going to happen. We're just trying to make it happen sooner. My name is Max Ventilla, and I'm the founder and CEO of AltSchool. Working in Silicon Valley and being at Google and, living here, it's kind of impossible not to have it shape your worldview and to believe that a mission-driven technology company can have an incredible impact beneficially on the world. And being a parent of young kids, there's really nothing I can think of that is more important than their education that I can be working on. As an entrepreneur, you have that startup bug. You need to work on something that catches you, and this was the thing that caught me. There's this problem, which is that the model that we have for educating kids, it is a mass production model. It's a factory model. It doesn't provide an individualized experience to kind of anybody. Every 45 minutes, kids switch to a different subject, and they open a textbook and they read the next chapter, and at the end of the week, they take a quiz. That experience is teaching kids how to think like computers, and that's not going to be very valuable when these kids actually grow up to be adults. If you're trying to fundamentally transform the education experience, that is not something that you can just kind of whiteboard with a bunch of research and a bunch of smart people in a room somewhere. You have to learn what that model looks like. For us, that meant immediately, almost from starting the company, opening a school. And then we opened 3 more schools, and then we opened 3 more schools, and now we're opening 2 more schools that are focused on personalized education. Each child defines their own experience to learn in a way that feels natural, takes advantage of their curiosity, and that doesn't try and corral them to learn this thing right now in this way. And that's where technology plays a foundational role versus a superficial role. There are 2 tools that fundamentally enable personalization in our schools. One tool is called the portrait. So this is a representation of, all the things that are important about each child that different people can add to for curating a day-to-day education experience that's going to meet them where they are. That maps to a second tool, which we call the playlist, which is the kind of scaffold for each child's day. It's a to-do list and a calendar. It allows each child to decide, what order they do things, or they can decide what's on that playlist as they get older. It's allowing a child to have agency. None of us like being told what we need to do, when, where, how, with whom. There's nothing that's more demotivating than that. And if you're not motivated, you don't actually learn. There's no way to force a kid to learn. They have to actually go along with a certain experience. They have to actually think. What we see is incredibly promising out of the gates in the first few years. We're seeing much more than a year's worth of progress on kind of nationally normed tests. But as importantly, they're making progress on the social emotional pillars. Things like grit, ability to work with others, ability to manage your time, to set goals that are going to serve those kids critically when, they enter a world that's going to demand those kind of characteristics from them. I mean, my daughter's going to have a different life because this is the kind of school that she went to. And I love this Bill Gates quote that humans tend to overestimate what we can accomplish in a year and underestimate what we can accomplish in 10. First year probably costs us $100,000 per student. The next year, it's like $60,000. The next year, it's like $35,000. This coming year, it's like $25,000. I think that when you get down to about $15,000 per student, now you're in the realm of the kind of median experience in lots of parts.
70% of the world's population will be living in cities covering less than 2% of the Earth's surface. Never have cities been so challenged, and the trend continues to grow. This raises many issues. Pollution. infrastructure access, traffic congestion, mobility, safety, and the health of residents are only a few examples. The development and combination of new technologies, such as the Internet of Things and artificial intelligence, offer a multifaceted solution: the smart city. Smart cities are hyper-connected cities, technologically equipped to improve the lives of their residents. In Mexico, some neighborhoods are still struggling to get permanent access to electricity. So the city installed sensors to analyze the use of electricity in various sectors, so as to optimize energy distribution across the grid. As a result, less frequent power cuts and better distributed energy. In the United Kingdom, the city of Bristol created the Data Dome, a public platform where information on traffic, air quality, noise, or even the city's governance can be shared. They want to grasp the city's pulse by exploiting this data and give local players, citizens, and entrepreneurs the means to build the smart city that truly suits their needs. At AXA, we want to provide our know-how to enable public authorities, businesses, and society as a whole to better anticipate the future, and thereby protect all actors living and creating the cities of tomorrow.
して振り回すと、そういったことができる非常に力持ちのあるロボットになっています。従来ですね、人間がクレーンを使って行っていた重量物の搬送、あとですね、専用機、消防機、そういったものを使ってですね、扱っていた重量物、そういったものをですね、ロボット、大ロボットを置き換えることができると、そういった非常に力持ちのあるロボットになっています。皆様中の方に進んでいただいてですね、パナックの知能ロボットをですね、
Workers in this Japanese factory have said goodbye to the assembly line and hello to the D shop. Roland DG is manufacturing everything from industrial printers to milling machines to vinyl cutters, using a single worker to assemble a product with thousands of parts from start to finish. These one-person work stalls, however, have a lot of digital help. A range of high-tech gadgets from 3D graphic monitors to digital screwdrivers help workers make every one of the company's 50 products.
約2日間にわたって組み立てに必要な基本的なスキルを身につける研修を専用に設けられたトレーニングルームで受けてもらいます。研修後は比較的短時間で組み立てすることができる小型のプリンターや小アッセンブリ、つまりユニットの組み立てから始めてもらいます。組み立てするにあたって、ネジ類の消耗品に関しては部品供給ラックから、取り出します。で取り出すとパソコンの画面には、電気ドライバーでビス止めするように
The computer keeps track of every step, ensuring correct components are used and the correct number of turns are applied to a screw. Workers' speed and efficiency are monitored, and bonuses are awarded based on productivity.
そのパソコンで、記録された工程の履歴をもとに早い人の作業っていうところはどういった工夫がされているのか、肝骨があるのかっていうところを、現場を管理しているスタッフが中心になってその膨大な生産ログを使って、しっかり分析して、分析した結果を教育であったり、実際パソコンの画面で表示される、作業指示、作業コンテンツの方に落とし込んで全員の底上げをして、ばらつきを抑制したりという活動を行っております。
While cell manufacturing, as it's called, isn't new, Roland DG says the use of digital gadgets speeds up production time, lowers defects, and helps it keep workers motivated in a market crowded with competitors. At the end of the day, the computer displays the time it took to complete the job and even gives workers a pat on the back.
お疲れ様でしたと。
Which means, you must be tired, and we thank you.
We think the main technologies that contribute to the factory of the future could yield over $500 billion of savings, which partly will be split between consumers and partly with equipment manufacturers. There are three characteristics that will define the factory of the future. The first one is a lot more things will be done virtually. Today you still prototype a lot of things, and sometimes when you're going to production you're still trying out layouts, which means from when a product gets first designed to when it finally gets to its end version that will be commercialized, you have a long lead time, which will be significantly reduced with new technologies, so product simulation, assembly line configuration, optimization. A lot of those things will start to be done in the virtual world. The second key characteristic of the factory of the future is the fact that it allows more human-to-machine collaboration. So, for example, today industrial robots work completely separate from human operators. With collaborative robots, commonly known as cobots, you will be able to allow the operator to work alongside the robot and each other to adapt his tasks accordingly. And the third thing is there will be more real-time communication between enterprise systems and the factory floor, and a two-way flow of information, which will allow for real-time optimization of the factory, remote control and monitoring from anywhere within the enterprise, not necessarily from the factory floor. Naturally, with all the focus on automation and cost savings that comes with the factory of the future, there are increasing questions about what this means for labor. We think what it means is that manufacturers will be more location agnostic in where they locate their capacity. They will be more focused on where demand is and where the best supply chains are, rather than on labor costs necessarily. We think what the factory of the future will result in is a very significant change in business models for both manufacturers and equipment makers for decades to come.
I am search of object. Now I get object's position. Now I move my arm to approach object. I move my arm to touch target. I close my hand. I move my arm to ready position.
Yeah.
I handle over a tip to my guest.
¿Qué pasó? Toda.
From Blacksburg, Virginia, Odin from Victor Tango's team number 32. Number 3 on the south end of the free zone. From Stanford, California, diesel-powered Volkswagen Passat station wagon, Junior. From Philadelphia, PA, Ben Franklin Racing Team, bot number 74, Little Ben. Bot number 79 from MIT is Talos. University of Central Florida's Knight Rider, bot number 13. Bot number 26 from Ithaca, New York, Skynet. Bot number 21 from Oshkosh, Wisconsin. It's called Terramax. Bot number 54 out of Palo Alto, California. It's called Anyway. From Pittsburgh, PA, Carnegie Mellon University, called Boss. Team Corolla, bot 62. Caroline is its name. From Intelligent Vehicle Systems, bot number 15.
Time for some adventures. Some breathing room. We've stepped out of the tested shop and we are actually in one of my old stomping grounds. I'm standing on one of the training courses for the Alameda County Sheriff's Department in Dublin, Pleasanton, California. Right over there is the bomb range where we blew everything up on Mythbusters. We swam in syrup over there. I learned how to tactically drive backwards in high heels right over there. It's the perfect location to test all of the things about Spot that we want to learn about. His gait, his ability to handle different kinds of terrain. All right, Spot, you ready? Let's go. These rocks and this tunnel underneath the rocks is the perfect first test run. I'm going to try him over, and then I'm going to try him through. All right, Spot. Oh my God! Oh, Spot, you almost did it! I'm gonna try this again. This is a really difficult thing for anything to walk over, but we're gonna give it our best shot. I think this is largely operator error, but we're just gonna keep on keeping on. Here we go. I've adjusted him to a crawl gait, and hopefully this will give him a more stable. Dude, Spot, you are amazing. Holy cow, buddy. That was amazing.
請け負ってるチームと、あとは全く先ほどの健康関係、電力計測ですとか、データセンターの熱がどうなってないかとか、そういった部分を制御する。
Vessels transporting passengers and cargo without any onboard crew might not be science fiction for long. Meet the Venus, an unmanned surface vessel, or USV, a 9-meter-long boat that explores the vast stretches of ocean autonomously. ST Electronics has launched its cutting-edge technology in Singapore waters, making it one of the first nations in Southeast Asia to build and deploy the USV.
There's a lot of potential in this need for this unmanned system. In 2008, actually we started our very first USV development, which is this boat itself, which I'm standing on. This is the 9-meter unmanned surface vessel that we first developed.
ST Electronics launched the first USV 7 years ago, when it was developed for military missions such as mine countermeasures and anti-submarine warfare. The technology that supports this craft is actually one that many people are accustomed to. The vessel's path is first charted out on a mobile device, which is able to determine its exact marine route, speed, and even behavior. Once its mission begins, the vessel uses its navigation sensors to build situation awareness and to identify potential obstacles.
We have a lot of sensors that are put in place to help the vessel localize where it is. At the same time, know where to go. We have software to control basically how a vessel guides itself from point A to point B. This is a navigation radar that transmits RF, right? So if there's an object there, radio frequency waves get bounced off all these objects and be collected back at this sensor. So over the scans, you're able to estimate whether all these objects are stationary or moving.
In addition to that, the vessel is well equipped with auxiliary sensors in the form of cameras in the event that the radar misses any obstacles. Now that the USV is tested, it is up to the market to define its commercial viability.
For example, you can actually just make a ferry boat carry passengers that is unmanned. Just like your MRT, where you don't need a driver to drive the MRT.
If you're talking about ferrying people, I think a safety number on board is still important. With the technology today, maybe he's just there to assure all the passengers in the ferry that at least the ferry is not driving by itself. More from a psychological assurance point of view.
ST Electronics has signed a 3-year Memorandum of Understanding with the Maritime and Port Authority of Singapore. Part of this MOU would be to research and develop the regulatory framework supporting the commercialization of the USV technology.
I think it's important for the authority to actually put in place regulation how the unmanned vessel could be coexist with a manned vessel on the maritime environment.
The USV holds vast potential as a technology, not just in removing humans from dangerous military missions such as minesweeping, but also in freeing up manpower from routine tasks.
For example, you have to do a watch keep on board the ship, physically using a binoculars to actually do watch keeping. Whereas if with all this technology, with all the artificial intelligence that you build into the system, you can actually do all this mundane work for the operator.
ST Electronics expects to complete the full-scale development of the Venus USV for military and paramilitary use by end 2017. Advancing the technology for commercial and passenger shipping purposes will be its next goal. Conventional sea travel as we know it is set for a wave of change.
Time
vendo o pássaro em corte, com maiores detalhes, todo o mecanismo com voo, e tem vídeo também. Para quem não conhece, um controle fora lá, vendo mais detalhes.
Let's say we've got a couple of robots wandering around exploring a room. The first robot might find something interesting. Using its sensors, it can know where that object is relative to itself. But how do we know where that object is within the overall world or compared to the other robot? Now, most of us could probably figure it out with a bit of trig, but as soon as you start to have more complex scenarios, and especially when you're working in 3D, that becomes really annoying. Instead, we can use this mathematical tool called coordinate transformations, or transforms, to take care of some of the load for us. The first step is we need to assign these coordinate reference points called frames wherever we need. So here we might have a world frame, a robot 1 frame, and a robot 2 frame. In case you're not familiar, we usually use red for the X direction, green for the Y direction, and blue for Z. Next, we need to create transforms between our frames. A transform defines how you would change from one frame to another. Transforms can also be used backwards, so if we've got all this information, then we know how to change any frame into any other frame, as long as there's a continuous line of transforms between them. We can calculate what the transform would be between those two frames. To avoid running into conflicts, we want our defined transforms to form a tree structure, which means that each frame is defined with respect to only one other frame. Each frame can only have one arrow pointing into it, and so you can't have any closed loops. Mathematically, if we have a system like this where we know how to change any frame into any other frame, then we can use that to convert points or shapes or vectors between those frames. As another example, imagine we have a gripper mounted to a bench with a camera mounted above that. The camera has detected an object and we want to know where it is compared to the gripper. For this system, we might create a transform tree that looks something like this.
This is Robotics Project 6. Neil is our demonstrator and our tester. Bentley on the camera is our scriptwriter and video recorder. And I'm Mike, I'm the researcher and the speaker. Today we're going to be doing a rectangle with curved ends. We're going to use circular motion to accomplish the curves. And all the straight lines are going to be linear motions. And Neil, whenever you're ready.
We are going to first start by creating the program. We're going to go to Select, Create, F2. We'll start with the word Program 6. Program 6. Enter. Enter. Now we're going to, this is our start screen. So first we're going to start with our beginning point, F1, because we're clear of the workpiece. Enter. Now we're going to move into the paper.
Now our first contact point is going to be away from our arc, because as the robot is lowering, it may not be able to accomplish the tangents of the turn on the first turn. So our first point,
take the paper, F1, enter. We'll go to the next point. Enter.
Now that's the first point of our arc. Our next point is going to be a circular point. Alright, Bentley.
Another point, enter. We'll go up and change that to a circular move. Choice, soft key F4. Enter.
Now, when that makes it blank, that means that that point that it just selected is an invisible point. So basically, it's going to go from the point prior to the point after, and it's still going to keep that other point in the middle in memory so it knows where to make the arc.
Right now I'm finding the last point of our arc. Now we'll hit Shift, touch up. That'll be the last point of our arc. So now we can clear the workpiece and move over linear to our start of our next arc. Turn up our feed rate.
Now this will be our point for the second arc. That was linear from that last point to this point. And once again, we're going to put the point as a linear point, and then we're going to change it to a circular point.
Change that linear to a circular. Choice. Enter. So now we can scroll down and then we can hit our Shift touch up because I'm at that last point. Shift C. Then we'll clear that. Now we'll go back to the robot and we will be
going for our next linear point to the next curve.
So we'll create this point. This will be the start of our arc. Enter. And our last arc will show you a different move of the termination type.
You're going to try it? You're the man. You're going to do a continuous on that one? Very nice.
Point.
And now we're going to change that one over to a circular move again.
Choice.
He's going to change it into a continuous move.
Circular.
So basically what we're doing is we're turning this into a continuous move. That way there's no points in between. It'll actually just sweep through the turn and move on. Shift touch up, that'll be the last move on that arc. Once again, we're changing the linear move to do this one as a continuous. So the bottom two are going to be standard circular motions, and the top two are going to be continuous motions. We're going to go to our last point on the part. That will end our points on the part. And now we're going to return to a home setting, away from the part. Okay, all right, now we're going to attempt to run our program. All right, and away we go. There's the first point, the linear move to the arc itself, the linear move to the second arc, we're going to stop move the arc. Now we're going to do the continuous move through the top arc. Linear move to the third, fourth arc, and a continuous move, and the final to our starting point, and then away from lift off the part.
Now I'm going to show you some demonstration. I am search of object. Now I get object's position. Now I move my arm to approach object. I move my arm to touch target. I close my hand. I move my arm to ready position.
Yeah.
I hand over object to my guest.
Basta, toda, so, okay.
This is a little tutorial to describe how to use the circular motion command. We're somewhat familiar now with the joint and linear motion commands. The circular command is a little more detailed or complex. So let's look at the little program I've created here. So far it's the part I've created for this to kind of demonstrate the circle command. It's it's just a cylinder with a circular surface to it. I've created two lines here. One is the home, which is just in the position it's in right now, and I've labeled it home. The next is the center, and if we step to the next step here, we'll see that it just goes down and touches the center of this face of the cylinder. The next step we're going to do is actually jump out to the perimeter of this circle by going in the negative Y and creating a point. That is going to be the start of our arc. Our arc path is going to follow the perimeter, or near the perimeter, of this cylinder face and end up with a half of a circle, which is an arc. The circular command's a little bit of a misnomer. It's not really a circle. It only can create an arc. And what defines that arc are 3 points. Remember, any 3 points on a given arc make that arc defined. They all three have to have the same radius point, and they'll create the radius and the length of the arc. And that's what's being done here. The tricky point is this start of the arc is just a normal joint move. It's the next position we create, which is the midpoint, that really starts the circle command. So let's move let's call this 0 position, this 90, 180, 270, 360, or 0, back to 0. So let's go to the 90-degree position by jumping in the positive X and Y. So let's go positive X and positive Y. And to get a better view of whether we're really on top of this or we're right in the 90-degree position, let's look at the view that looks directly overhead. And that's not bad. We're pretty much there. Let's bring it to the center. Zoom in a bit. And let's create a new point. Somehow or another, grab 2 points. I'll go ahead and jump up. And you know, this simulator is a little finicky. I think, well, it's just something to be able to go to the next screen, edit command, and let me delete that extra. I want to confirm it, yes. So now we have our point 4, which is the 90-degree position. Let's go ahead and label that even, just so we better describe how we're defining this. Let's call this the 90, or mid point. Let's go back up and define this guy as our start. Jump back down. This guy really doesn't, it's not a joint. In order to create a circular move or an arc, we're going to have to change this and come over and select choice F4 and choose circular. Notice when we do that, it actually creates another position, which is our final or third position of our arc. We'll have to jog to that position and touch it up. That's how you actually define the end of an arc. It's actually, it automatically throws that point in there, but it's undefined at this point, and we actually move. Let's move in the minus X to get back to our center point. And into the positive Y. These aren't going to be perfect arcs, but you get the point. And then let's touch up that point. We have to come down and actually bump out away from this guy and touch up. Again, it's a little finicky, so let me try and touch up again. the shift and touch up, and that's now our end of our arc, or end of the third of 3 points to define that arc. Let's actually come over and define that guy. Enter endpoint. Forget my typing here. So now let's go ahead and play this guy and see what it actually looks like. Then let's actually go into the view and go to program details and display position and triads. You notice now we have point 1 and 2 are directly over each other, so they appear to be. You notice point 1 is our home position, point 2 is the center of our circle, point 3 is the outer, it's just getting to the outer perimeter. Point 4 is where we came out and defined our midpoint and changed it to a circular command, and it automatically created this endpoint over here, point 5, and we but didn't define it, so we had to jog over and actually touch up that point. Let's go ahead and play this guy and see what it looks like when it actually goes into the motion path. Just going to go back home first, jump out to the outer perimeter, and then you notice it does the arc move. So that's our half of our circle. If you want to create a full circle with this, you're going to actually have to create a few more motion steps.
Now I'm going to show you some demonstration. I am searching object. Now I get object's position. Now I move my arm to approach object. I move my arm to touch target. I close my hand. I move my arm to ready position.
Yeah.
I handle over object to my guest.
¿Qué pasó? Toda. So, ajá. Ajá.
when I gave the word. Now in the morning I sleep alone. Sweep the streets I used to own. I used to roll the dice, feel the fear in my enemy's eyes, listen as the crowd would sing. Now the old king is dead, long live the king. One minute I held the key, next the walls were closed on me, and I discovered that my castle stand upon pillars of salt and pillars of sand. I hear Jerusalem bells are ringing, Roman cavalry choirs are singing. Be my mirror, my sword and shield, my missionaries in a foreign field. For some reason I can't explain, once you've gone it was never, never an honest word. That was when I ruled the world. It was a wicked and wild wind, blew down the doors to let me in, shattered windows and the sound of drums. People couldn't believe what I'd become. Revolution